We now determine the coordinate of the vertices of the ellipse given that two foci. The coordinates of the two foci are 14, comma negative 1 and negative 10, comma negative 1. And we are also given that the length of minor axis is 10. So here I have drawn this ellipse with foci, that is F1, this is the focus 1, and this is another focus. I have marked the coordinates as such given here, and V1 and V2 are the vertices, that is we have to determine the coordinates of these two vertices. And we are also given the length of minor axis is 10, that is the length of minor axis according to this ellipse 2b is the length of minor axis, that is this total length is 10, so we can determine b from this one. B equals 10 by 2, which gives 5. Now we will also determine the length c using the two foci coordinates. That is, since this distance is c and this distance is also c, we can see that 2c equals the distance between the two foci. That is, one foci is at negative 10, comma negative 1, and another foci is at a distance, that is the coordinates of the second focus is 14, comma negative 1. Since the horizontal coordinates, the vertical coordinates are the same, we can just simply find the absolute difference between these two x values. That is, we find 14, negative, negative 10. We find its absolute value. This gives the distance. So this equals 14 plus 10. Its absolute value is 24. So we see that the distance between the two foci is 24. That is 2c equals 24, and this means we can determine c by dividing both sides by 2, so which gives 24 divided by 2 is 12. So we have determined the c equals 12. Now using the relation c squared equals a squared minus b squared, we can determine a. So I'm going to plug in c equal to 12 here. So it becomes 12 squared equals a squared minus b equals 5. So it becomes 5 squared. I can put it here. And from this, we can calculate a. So this is 144 equals a squared minus 25. Now I add 25 to both sides and have only a squared on one side. And this gives 144 plus 25. So a squared equals 169. We now take a square root on both sides to determine a. And this gives a equals 13. A equals 13. Now let's see how to determine the coordinates of the two vertices. Since we have determined a equals 13, we can see that this distance is 13 and c equals 12. That is, this distance is 12. And therefore, we can determine this distance. That is, the total distance a equals 13 and c equals 12. So therefore, we can see that diagrammatically this distance is 13 minus 12, and this equals 1 unit. And this means the vertices 2 is at a distance of 1 unit to the right of the focus at which is whose coordinate is 14, comma negative 1. So all that we have to do is in the x coordinate of the focus 2, that is 14, we have to add 1 to the x coordinate of the to get the x coordinate of the vertices. So when we add 14 with 1, we get 15. So therefore, we can see that the vertices of uh, the second vertices, which is now labeled as V2, and this is 15, comma negative 1. And similarly, we know that this distance is 13 as well as this distance is 12. So therefore, we can see that this distance is 13 minus 12, which is 1 unit. And this vertex 1, this is 1 unit to the left of the focus F1. So we have to subtract 1 from the x coordinate of the focus 1. So when we do that, we get negative 10, negative 1, and this equals negative 1. So this becomes the x coordinate of the vertex 1, and the y coordinate remains the same. So therefore, we say that one of the first vertex, which is labeled as V1, we can write down its coordinate as -11, comma -1. So we now see that the coordinates of the two vertices are -11, -1, and another one is 15, comma -1. So these are the coordinates of the two vertices. And so answer choice 4 is correct.